This problem, we're going to sketch the graph of f of x is equal to x to the fourth minus 4x cubed. We're going to sketch the intercepts, local extrema, points of inflection, and asymptotes. First, the easy thing, there are no asymptotes for this one. This is not a rational function, and so there are no asymptotes to worry about. For the intercepts, so let's solve f of x is equal to 0. So x to the fourth minus 4x cubed equals 0. X cubed times x minus 4 equals 0. And so I have intercepts, x-intercepts at x equals 4 and 0. So those are the x-intercepts. What I'm about to do is redundant, but we'll do this anyway. Y-intercept is what I get when I plug in 0. So f of 0 is 0 minus 4 times 0 is 0. And I already knew that because 0 was an x-intercept, and so therefore the 0 will also be a y-intercept. Okay, now we find the local extrema, places where the function is increasing and decreasing. To do that, we find the derivative. So f prime of x. The derivative is 4x cubed minus 12x squared. And that factors as 4x squared times x minus 3. Okay, so the points of interest, so the terms are 4x squared, x minus 3. Multiplying together, I get the derivative f prime of x. The points of interest are 0 and 3. This does not have to be drawn to scale, but I should put 0 to the left of 3. 4x squared is 0 when x is equal to 0. Otherwise, it is positive. X minus 3 is equal to 0 when x is equal to 3. If I plug in something bigger than 3, it is positive. If I plug in something less than 3, it's negative. Okay, so multiplying together, positive times negative is negative. 0 times negative is 0. Positive times negative is negative. And then 0 here. And then positive times positive is positive. So the net effect is that the function is decreasing to the left of 0. It is decreasing to the right of 0. And it is increasing to the right of 3. Okay, now we've determined points of inflection. To do that, we need the second derivative, f double prime of x. So if I take the function here, 4x cubed minus 12x squared, if I take the derivative of 4x cubed minus 12x squared, that is 12x squared minus 12x, sorry, minus 24x, pardon me. And so this, I can factor 12x out, 12x times x minus 2. Okay, so the terms are going to be 12x and x minus 2. Multiplying together, I get the second derivative. Points of interest are going to be 0 and 2. 12x, that is going to be 0 at 0. It is negative to the left of 0 and positive to the right of 0. X minus 2 is 0 at 2. It is negative to the left of 2 and positive to the right of 2. And so multiplying, negative times negative is positive. 0 times negative is 0. Positive times negative is negative. Positive times 0 is positive. Positive times positive. Positive times 0 is 0. Positive times positive is positive. And so the practical upshot is that the graph is going to be concave up to the left of 0. It is concave down between 0 and 2. And it is concave up to the right of 2. So I can see right away that 3 is going to be a local min because it is changing from decreasing to increasing. There is not going to be a local min or a local max at 0 because it's going from decreasing to decreasing. I also see that I'll have a point of inflection at 0 because the concavity changes. And I also see I have another point of inflection at 2 because, once again, the concavity changes. Okay, so with this, we can now start sketching the graph. And it's probably a really bad sketch. Let me start over again. Okay, so I know that I have intercepts at 0, and I also have an x-intercept at 4, and I also know that 0 is a y-intercept. I also know that this is going to be a point of inflection. I also know that the number 3 is going to be a local minimum. And so if I plug in f of 3, f of 3 is equal to 3 to the 4th minus 4 times 3 to the 3rd. That's equal to negative 27. And so the point negative 3, 27 is going to be on the graph. And that's a local min. I also know that 2 is a point of inflection. So when we plug in 2, f of 2 is equal to 2 to the 4th minus 4 times 2 squared. 2 to the 3rd, pardon me. It's 4 times 2 to the 3rd. And so that's 16 minus 32 is negative 16. And so that'll be somewhere around here. That the point 2, negative 16, that is a point of inflection. Okay, so to the left of 0, the graph is decreasing and concave up. So the graph's got to go something like this, decreasing, concave up. Between 0 and 2, the graph is decreasing, but concave down. So something like this. To the right of 2, it is concave up. So, but until I get to 3, it is decreasing. So it's now going concave up. And then I hit this minimum. And then at 3, it is now concave up and increasing. And so something like this, where I've got this point inflection at 2, negative 16, and a local min at 3, negative 27, also a point inflection at 0, 0. That'll be in a sketch of the graph of this quartic polynomial.